Hi folks, it's been a little while since I've made a video. I was asked this question yesterday by Hayden, so I thought I would work through the example. Please don't forget that there are examples in your textbook, so if you're getting stuck, go back and have a look at the examples that are in the textbook. It might give you some help, and also check out the Cambridge website because they often have some video examples as well for each exercise. But I will work through this one and hopefully I can provide some extra help and tips that help you along the way. So the first point I want to make is when we write a function, so this is my function p of x, and we're using p to say that p is a polynomial. When we write a function in this form and we stick a number inside the brackets, because it was p of x up the top and now I'm putting a -1 in the brackets next to the p, all that's telling me to do is to substitute x equals 1. Or in this case, sorry, -1. So this tells me here to substitute x equals -1 into the equation. So when I do that, I end up with, alright, so p of -1 will be equal to 3 times -1 to the power of 6 minus 5 times -1 to the power of 3 plus a times -1 squared plus b times -1 plus 10. So there's my expression. I've substituted in all of the -1s. Now I try and put what I'm substituting, I try to leave it in brackets just so it stands out and makes it a little bit easier. Not required, but it's a simple tip to make sure you don't lose track of your negative signs. And we often have trouble with our negatives and positives. It's really common to make mistakes with negatives and positives. So that's a simple technique to try and avoid that from happening. Now, if I have a negative number to a even power, it'll be a +1. And if I have a negative value to an odd power, it will become a -1. So this becomes 3 times 1, which is 3, minus 5 times -1, which is +5. And then -1 squared is +1, so it becomes plus a. And then -1 to the power of 1 is just -1, which is minus b, plus 10. So I've kind of got my right-hand side of the equation here. What do I do with the left-hand side? Well, the hint is how they wrote this definition. And it tells me that p of -1 and p of 2 are both equal to 0. So this expression here will be equal to 0. And I can write 0 equals a minus b plus 18, or I could then write -18 equals a minus b. And you might have recognised by rearranging, I'm heading towards this space of creating simultaneous equations, and that's my first equation. So we've substituted in -1. Now let's substitute in the 2. Okay, and we're going to put that in this expression up the top, just like we did the first time. So let's start again. If I substitute in a 2, my hint is write the brackets for what you're substituting in. Okay, which gives me that. So now I've got to do a little bit of simplification. Do not forget that 2 to the power of 6 doesn't equal 12. It would still be common for people to do 2 to the power of 6 equals 12. So basically I've got to double. I'm using my indices. So it's 2, 4, 8, 16, 32, 64. So this becomes 3 times 64. 2 to the power of 3 is 8. So 8 times 5 is 40. And then I have plus 2a plus 2b plus 10. And again, what goes on the left-hand side? Well, this is still equal to 0. So now I've got to tidy up my equation. 64 to the times 3, well 60 times 3 is 180, 4 times 3 is 12, so that's 192. Take away 40, plus 2a plus 2b plus 10, or 202 take away 40 equals 162. Plus 2a plus 2b. And then finally, I can divide everything by 2 here, and I'm going to make that 81 plus a plus b, and then negative 81 equals a plus b. Alright, now I've got my second equation. So I've got two unknown values. I've got to try and find out what a and b are. So I've got two unknown values and I have two equations. So the easiest way to do this is through solving simultaneous equations. And because these equations, I've set it up so I've got an a take away a b and an a plus a b. The easiest way for me to solve this with simultaneous equations is to just take equation 2 and add to it equation 1. So if I have negative 81 plus negative 18, that gives me negative 99. If I have a plus a, that's 2a. If I have b plus negative b, well, that equals 0 b's. And of course I don't need to write 0 b's. I just wanted to have that as my discussion point. So from here, I get a equals negative 99 divided by 2. Right, you would have just seen a message pop up from my wife saying she's on her way home from work. Just ignore that. Okay, right, so now the last thing I need to have is I need to work out what b is equal to. So the easiest way to do that is I'm going to substitute this a equals negative 99 on 2 back into one of my equations. If you want to work in decimals, you can, but I've been encouraging you to use fractions. It's really good practice and does become easier when manipulating your algebra skills at a later date. So let's have a crack at using this fraction. Now I can use equation 1 or I can use equation 2. And in this case, I'm going to use equation 1 just because the numbers are a little bit smaller. So I'm going to substitute a equals negative 99 on 2 into the rule, or into equation 1, which gives me negative 18 equals negative 99 on 2 minus b. So if I add the b, I can do this a couple of ways. I'm going to add, I'm going to add the 99 on 2 to get negative b. So if I add 99 on 2 to do this addition, I need a common denominator. So I'll make that negative 36 on 2 plus 99 on 2. And the easiest way to do that is 99 take 36 is 63. So that'll become 63 on 2. Now this is equal to negative b. Be very careful. We don't want to know what negative b is. I want to know what positive b is. So positive b will just equal negative 63 on 2. And I've got my two answers. I've got my value for a, and I've got my value for b. So the final thing I probably should do is say something like, therefore, a equals negative 99 on 2, and b equals negative 63 on 2. Now I haven't checked those answers, so I might have made a mistake somewhere along the line. If I did make a mistake, the theory is correct, and this process is the correct process, so you can go from there. Now I might add one extra bit of information here. This is a really great question to do on a calculator once you get to the stage where I have my two expressions. So on your calculator, once you get to this point here, and this point here, you can solve that on your calculator using simultaneous equations. You've got two equations, so you can actually just go in and you can enter those two equations and you use the solve function on your calculator. If you're not sure how to do that, then that would be a good question for you to ask me at a later time. All right, thank you.